Hello, hi, and welcome to the video demo of the Python language training. Here I would introduce you to the Python language, the concepts of how you will have to code using Python and how to extract necessary results using Python. So the first prerequisite for you would be to install Python, and you can follow what you see on your screen to get Python downloaded. The latest being Python 3.5.2. All right. So after you get to download Python, you certainly need to have an editor to code in your Python scripts, right? There are plenty of IDEs. You can hit the wiki page to know the Python editors, but what I use is PyScripter. So here we go. The syntax in Python for a variable does not really expect if it is an integer or a double or a float or a character as in C++. Rather, you can directly go stating what a variable should be assigned to. So if you say x is equal to 4, it understands that x is an integer value of 4 and my underscore string of 1 is equal to double quotes. This is a string is understood to be a string. Now you will have to notice that if you've started with the double quotes, you better end it with a double quote. If you've started it with a single quote, you will have to end it with a single quote. All right. Now, what is an indentation in your coding? That would define the block of your coding. Unlike C and C++, you do not have curly braces to define the block of your code. Rather, in Python, you will give an indentation. You will give spacings. You will give spacings to help Python understand that that is a block of code. For example, on screen, if you see the if condition, if x is double equal to 1, that means if x is equal to 1, then you would give a spacing. The best practice is to press the tab button, which would automate your spacings to 4 spaces. And so print x is 1 comes under the if condition. The else condition would be 4 spaces back, because if you had the same 4 spacings and if it comes under print, then the else condition is something that would get executed under the if condition, and you would find an error because you will need a separate if condition to really write an else condition. So bring that 4 spaces back for that to make sense that the else condition is for the if condition in line number 11. Alright, so these are certain rules that you will have to follow when you get to code your Python script. Let's go to the next slide, and we are going to speak about numbers, strings, lists, tuples, and dictionaries. Alright, these are going to be the data variables that you can use in your Python scripting. Numbers, there are many built-in functions you can use in numbers. For example, the power of, the absolute, the square root, rounding it about, random variables. Trigonometric functions are also built. So x is equal to 2.5, that's a double with a decimal. X is equal to 5, e power 4 is nothing but 5, 10 raised power 4. And then you can get complex numbers, and x is equal to power of 5, comma 2 would give you 25. So these are how you can utilize the built-in functions in Python. Getting next to strings. Here I've got a declaration of string is equal to this is a string. You should understand that a string is stored as an array. Alright, so here if you see there are 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's a total of 12 strings in the just defined str variable. So what does str of 0 give? It gives the letter T, because T is in the first position and the positions start from 0. You can also access the fourth to the sixth character by stating str of 3 colon of 6, and str of 3 colon would give you the total string after the third position. Right? You can concatenate strings by just adding two strings with a plus operator. Okay, and these are the objects that you can utilize under a string variable. If you say capitalize, then it would transform the first alphabet of your string to uppercase. Count would give you the number of times uh, the string has a particular character that you would state as a parameter in your count. You can also find if a particular uh, variable is there, if a particular letter is there in your string, and you can have an if condition to see if your string ends with a particular string. So these are object functions of your string that you can use. Alright, now the next thing is lists. Lists are nothing but they are again arrays. I'm gonna have this as a presentation. I'm sorry for. Okay, so what are lists? Lists are nothing but they are a container that stores values for you. Those values really do not necessarily need to be integers or characters or Boolean variables. They can be anything that you can push into a list. So in the example over here, if I say my list is equal to 1, dot, 4.238, my list has 3 items in it, and in the 0th position I have 1. In the second position I have dog. In the third position I have a decimal variable. Alright? Sure, you can also declare a list with square brackets, and then you can again print the items of your list as similar as how you did it with the character. You can add to lists as shown here. So if list 1 has 3 items and if list 2 has another 2 items, then my list of 3 would have a total of 5 items. You have similar objects in your list where you can insert a particular value at a particular position of your list, and then you can reverse your list. Pop would mean that you want to remove, a particular value at a particular position in your list. Remove would mean that you want to remove a particular value from your list. Now, the difference between lists and tuples are that you can modify your list, they are mutable. Okay? You can modify your list by deleting or by inserting a new value at a particular position or by dot appending. Dot append means adding a new value at the very end of your list. But those you can modify your list, but in tuples they are immutable. You can never change anything inside your tuple. So if you declare your list in square brackets, your tuples will be declared with the curly braces. Alright, moving on. What are dictionaries? Dictionaries are similar to what a map is in C++. Alright, so my dictionary can be declared like this. For example, a dog would bark. So I would say my dictionary of dog is equal to bark, and this would be the key value against the item, against the value that is stored against your item. Sure. So my adjective cat is equal to meow. You can print the values of your dictionaries by saying print my adjective dog, and that would print bark for you. Sure. I would like to show you guys an example of what I'm talking about. So inside my main function, if I would show you what these are. If I have if I have my dictionary, if I'm gonna say my dict is equal to a dictionary, and then I say my dictionary of dog is equal to bow, and then if I say my dictionary of cat is equal to meow, I can always use a for loop. I can always use a for loop. I can say for the key value in my dictionary. All right. Then you get to say print key. No, you've got to say print my dictionary of the key value. This is how you would extract the necessary values from your dictionary. I want to show you how this is going to work. And on that note, this is how my dictionary is going to look. Cat, colon, meow, comma, dog, comma, bow. And you see this, the first key would be dog, and I can print this. I can print this by saying my dictionary of key. You get bow. Alright? So the next one would be meow. That's the value. So this is how you can utilize dictionaries. You can have anything stored in your values. You can have a list as your items to a dictionary which has a key value of a character or an integer. It is always advised that your key values be a scalar value. That's recommended at least from my side, because a scalar value would help you in comparing that value to some other value of your interest. Rather than having a list in your key, I mean, you wouldn't be able to really compare that against a scalar value, is what I mean to say. Sure, so let me just delete what I just wrote, because I've got this file for you all to understand about classes. That's a topic that's coming up. Alright, so we just saw what dictionary was. Miscellaneous. Sure, methods to convert from one type to another. I can convert a string to an integer by just saying a is equal to int of x. I can convert an integer from an integer to a float, as well as I can do I can convert an integer into a string. I can convert an integer into a string, as well as an integer into a character or a hexadecimal number. I can delete a character too by just saying del of the character name. Alright. Arithmetic operations, very, very similar and simple as in C++. If A is 7 and B is 3, then A divided by B, A modulus of B would give you the remainder of what you've divided. And A star star of 2 is to the power of 2. If you say 7 to the power of 2, you can say 7 multiplication of 2. I mean the operator. Going on, logical operators, if A is equal to 3 and B is equal to 4, then these are the logical operators that you can use. If A is equal to B, if A is not equal to B, you can also use the and the or operation as shown on screen. If A is 3 and if B is 4. If A is 3 or if B is 4. This is how you would do it in Python. Assignment operators, yep. If A is equal to 3 and B is equal to A, then if you assign A is equal to 2, B is still 3. that did not change. That's right. If A was 3 and if you say B is equal to A, then B is equal to 3. But even after you say A is equal to 2, B would not change. You can print and see what the address, the memory address of these variables are. And if A is a list of 1, 2, and 3, and then you say B is equal to A, and you try to append a new value into A alone, then you would see that B also would have the same appended value in it, unlike what we saw with a single variable. So you can print the address of it. B is equal to list of A would become a new list. They would not carry the same address. B is equal to A would carry the same address. B is equal to list of A would not have the same addresses when you try to compare B and A. So if you said B is equal to list of A and you get to do this operation of A dot append of 4, you would not see the number 4 in your B list. Alright, so moving on. So now moving on, I've got to show you, yep, the if-else condition. The if-else condition. If x is equal to 3 and as stated earlier, we've got an indented block for Python to understand that that's a block. And the if, and then this is the else if condition, the else if, and then the else. So this is how you go about an if else condition. This is how you would state an else if condition. All right. Loopings in Python are very, very simple as what you see. The while loop is as similar to what you do in your C++ while x is lesser than 10. Don't forget to put the colon after your if condition or a function definition or an if condition. Don't forget to end your line with a colon. That's important. So while x is lesser than 10, you want the loop to still go on. And this is iterating between a given value. So for x in the range of 10 would mean for x in the range between 0 to 9. Alright? And then for x in the range of 4, 16, 2 would mean your starting value is 4, your ending value is 16, and you would increment that by 2. We can also iterate over any list by saying for animal in my list, for animal would give you cat, and then iterating through it would give you dog and then bird. Rather, if you do not want to really get into directly to the value of what is stored inside your list, you would say you would want to access it in terms of an iteration of the positions in your list. For that, you would say for I in the range of length of my list. Length of my list in this example would be 3. So you would iterate with 0, 1, and 2, and henceforth you would access the item in your variable by my list of I, which would iterate as 0, 1, and 2. Alright, moving on. Loop controls, yep, you can use the break statement and the continue statement based upon your if conditions, and this is how you use it. The pass statement does nothing, you just want to pass through. If x is equal to 5, you do not have anything to do with it. You can just specify pass. Exception handling. Sure, so my list, you've got a list of just 3 items, but you're trying to access the 4th item in your list, which really is not there, which really is not available. So your code would crash. But if your code would crash, that would be really embarrassing. So you can do your exception handlings by saying try print my list of 3, and if that happens, hey, you've got to really throw an exception, and you say except index error. So you don't have that many items in your list as what you would print. I thought I do have a program to show you that. Let me try to show you that now. Here we go. I've got my list of 1, 2, and 3. And if I say print my list of 4, if I did not really have a try catch, then that's going to crash my program. But just because I have a try catch and I've thrown an exception, you will be getting global name index error is not defined. I think it should be index error. Yep, that you should be careful with the spelling, please, because except that should be capital E. And now let me try to do it. So here we go. Yep, so it's going to work. So except index error is an inbuilt exception handler for you in Python. And then you say you don't have that many items, and so your code is not going to crash. Else, you just saw how a code would crash in Python. There we go. Moving on. Function definitions. How do you do function definitions in Python? Define a sum. This would be your function name. This would be the parameter. And don't forget to put the colon. And don't forget to specify the block. Alright, with the spacings. Now, the returning multiple variables, yes, inside your function, instead of really returning just a scalar value, you can always, it is a scalar value, but then you can return n number of variables that you may need outside your function as a return value. So here, if you're going to return 2 variables, then you better receive it with 2 variables, because if you say return a comma b, and if you would receive it with only m, then you're not going to get the value of b. Alright, moving on. The pitfalls of your function calls are that if you have defined a list of 1, 2, and 3, and then you get to pass that list into your function call, and if you get to do anything inside that function call, that gets updated, and your list would still reflect the updated value even outside your function. You know, you have declared a list just above your function call, you've passed that list, and so whatever happens inside that function, you are going to get the reflected value even after coming out of the function. But now, I want to explain this. You haven't really declared a list, or maybe you've declared a list and you're passing the list into a new list, and inside that function, you have another list which is local to it, and you say 4, 5, 6. But then when you come out, you will see that your list did not really change. You may have to say mylist.append. Only when you say mylist.append, when it comes out, you will get it as an updated value. But then if you're going to assign a new set of values to your list, then that's not going to reflect outside your function. Modules, if you've declared a file, if you've got function calls in a file, for example, if you've got mathematical computations as function calls in a separate .py file, you can invoke that file inside any of your files and utilize those functions that you've defined. Import function test was a file which had function of sum to sum up all the items in your list. So you would just say function underscore test, which is your .py file, and then your function underscore test would become the namespace. So using the namespace, you would specify with the dot operator to get the function call. Moving on, this is again about your modules. You can say import your function underscore test. Otherwise, you can rename your function underscore test as how you would want your namespace to be named. And that's import function underscore test as ABC, and then you use ABC to get the function call of sum. Rather, if you want to just call the functions directly, this is the method of importing your function underscore test from function underscore test import star. You can choose the kind of function that you want to use. So from function underscore test import add item and just call this is an error. This is an error. You have imported add item, but there's no specific reference to the function call of sum. This would invoke all the functions defined in the file, but this is specifically calling a particular function. So you may be able to use the add item function, rather you cannot be using the sum function. Moving on, files and directories. Yep, this is another module. OS, import OS, you can get the current working directory with OS, and then OS, you can change the working directory, you can change the directory, you can also create a new folder, you can rename a folder with your OS with the OS interface. You can also check if there really exists a file for a given path, and then you can split your file path into the folder name and the file name as shown on screen, and then you can walk through all the files in a given directory as shown on screen using the OS interface. Now, very simple GUI for inputs from the user can be used through raw underscore input. Enter the value of X. You would get a small bit of a dialog box wherein you get a text control for the value that you can enter. How to read a particular file using Python. You can specify the file location, and F is equal to open of a file name, comma R means you're going to just read the file and read lines one by one, and then you have a while condition to check if you've reached the end of the file. Alright, and if you want to write, you would specify W instead of R for read, and then you can say F2, which is the object, to write a particular line into the file. Don't forget to close your object. Moving on, object-oriented program. I guess this is the last topic. Yes, you can do object-oriented program using Python, the type of programming where developers define not just the data type of structure, but also the functions that can be applied to it. Programmers can create relationships between these object types. One object type can inherit characteristics from another. This is called inheritance, as in C++. What is a class? All of the elements we've encountered so far were integers, strings, and lists. These are object types. A class can contain different kind of data variables, integers and characters, and lists and dictionaries and tuples, all embedded under one class. So a class is a user-defined object type. A class is a blueprint for the object. An instance is the actual object. So using the instance, you will be accessing your data variables of your class. Classes can contain data, other variables, and functions. The idea is to group together data and functions that are related to each other. Sure, advanced features of classes, reference counting. If you've got a data variable for counting the number of objects, instances of the classes that were created, you can have one and go by incrementing it. You can also have a destructor to delete the objects. I would like to show you a small demo on classes. And so here we go. Alright, so I've got a class called pet, and define underscore underscore init underscore would be the constructor of a class. When you instantiate your class, this would be the first function that Python calls. And then I've got other function calls. I also have a single underscore, and a function name would mean it is a protected function call. A double underscore and a function name would mean that that function call is private to that class. these are the accessibilities of how you do object-oriented programming in Python. I've got a bird, I've got a class called bird, and I am inheriting the base class of pet. Let's see how it goes about. I'm going to say F9 to this file. I've got poly is equal to pet of poly, and this is going to be my object. This is going to be my object instantiating it for the class of pet. And so this is going to call this particular function. The name is poly and the species is parrot. Now let me try to say F8. And when I say F8, I'm going to get this message that poly is a parrot because I do have a function call that states this, you know? And then if I can come down, I am not allowed to access the private member variable. But in Python, this is called name mangling. You can still get to access a private function by saying a single underscore, the class's name, which is the base class, and then the underscore private. You can still call it. Python's flexibility says so. All right. Now I can delete my object by just saying delete poly. Now after I delete poly, I cannot use poly, the instance of the class of parrot, in my bird class because I've deleted it, and you can see what the code shows. It's going to crash. It says local variable poly reference before assignment just because we deleted him. So let me just get back. If you use the string variable, if you use the hash variable, then that means you are commending the code. You are commenting the code off. That's not going to work. All right? I'm going to show you how this is going to work. And yep. So now you can call in poly. Oh yeah. So what does this mean? Poly is the object of the base class. But if you see, I have self is the instance of its own class. I've got name and living thing, which is supposed to be parrot and poly, but then I am passing the object of my base class, which is just not defined over here. If I would say pet, then this would work. If I would call this as bird of parrot, bird and poly, right? I hope this makes sense. But for now, I'm just going to carry. I am going to show you what exactly did I mean over here. Alright, I'm just going to instantiate it with those two bird with the parrot and the bird. And okay, so it takes exactly 4 arguments, 3 given. I shouldn't have really put this over there. Let me take that off. And now, yep, so it goes through. And bird.call private function. I'm calling the private function. No, this is just a function call, but you can access a private function call from within the class of your base class. All right. So inside this, I'm going to call underscore private, and that is going to give me private function of pet. And this is what we did. And this is what we get. So this is how you do object-oriented programming using Python. Moving on, I guess this is the last slide. You can always query for help for a particular variable. If you say help of int, you get quite a lot of useful tips that you can do using an integer or a string or a list of how you can use the objects of these data variables. Or I would like to show you one. So if I say help of int, then if I give my breakpoint here and if I press F9, if I press F9, yep. So this is what you get. It tells you what exactly you can do about using an integer. If you would say, you have the absolute function, you've got the add function, you've got the compare, you've got the divide, you've got the float. So what does this mean? If I would say, x is equal to 5, if I say x is equal to 5, and then I say x is equal to x dot underscore add. If I say x underscore add of 10, and if I would print x, and that's it, I would show you. You get 15 over here. If you see, this is the summation of 5 and 10. Alright folks, so this is all that I have about the Python training over here. There's lots and lots you can do about Python. If you would be interested, or if you've got any doubts, if you want training, or if you want a real in-class training, kindly get back to us. Let us know your interest, and we would certainly be happy to let you know more. Hope this tutorial helped you. I encourage you to really work around